If you're watching this at night, maybe the room is dark and the screen is the only light you have. Somewhere far beyond that glow, something small is crossing our solar system, and it isn't moving through it quietly. Hey everyone, welcome back. Today, NASA logged new data on 3IATLAS, and what made me stop wasn't that it looked beautiful. It wasn't that it suddenly got brighter. It was the feeling that something inside it has started to wake up. To make sure you don't miss the next change in 3IATLAS, subscribe now, and I'll bring you the latest NASA updates as soon as the data lands. Most of the time, once a comet has passed its peak activity, I expect the story to soften. The tail thins, the coma smooths out, the chaos becomes a slow fade. But with 3IATLAS, the newest signals are doing the opposite. Spiral, like structures forming in the coma. Fresh jets switching on. Venting that looks like it's coming from deeper interior layers, not just the surface. Taken together, it doesn't feel like an object calming down. It feels like an object reorganizing. And that's why I want you to stay with me for the next few minutes. Because I'm not going to throw everything at you at once. I'm going to do what observational science actually does. One signal at a time, each clue digested before we stack the next. So by the end, you won't just see that 3IATLAS is changing. You'll understand why the changes appear to be accelerating, and what that rapid evolution could lead to next if deeper material keeps getting exposed to sunlight. So let's start with the first sign, the one that, if you watch closely, looks like the comet is drawing a moving map into space. 1. The spiral signature. When a coma starts drawing patterns, if you want to know whether a comet is merely active or dynamically evolving, you look for structure. A smooth, evenly bright coma tells me the comet is releasing material in a broad, relatively uniform way. But when the coma breaks into arcs, shells, or spiral-like features, that is a different story. That is often what happens when collimated jets are firing from specific vents on a rotating nucleus. The nucleus spins, the jets keep venting, and the emitted material traces curves that can look like spirals or pinwheels as sunlight and viewing geometry do the rest. In recent reporting tied to observations from Spain, astronomers describe jet spiral structures coming off 3IATLAS. Even the imagery, shared in broader coverage of the International Asteroid Warning Network campaign, highlights what appear to be spiraling jets shooting off its surface. That detail matters because spirals do not just mean it is active. They imply timing. They imply rhythm. You can sometimes back out a rotation period, or at least constrain it from how fast those arcs expand and how the geometry repeats. And here is the tension. If the spiral patterns are becoming more pronounced over time, it suggests the jets are either strengthening, multiplying, or switching on in new locations as illumination changes and subsurface layers respond. That is not a comet stabilizing. That is a comet changing its active map. 2 new jets, new vents. The comet turns sunlight into direction. Now, I want to focus on the most cinematic kind of data a comet can give you: a jet. Images earlier in the encounter showed a dramatic sunward jet, the kind of feature that instantly triggers 2 reactions in the public. First, amazement, because it looks wrong. Second, suspicion, because it feels purposeful. But in comet physics, a sunward jet is not a contradiction. It is a consequence. As 3IATLAS neared perihelion in late October, telescope imagery showed a fan-shaped break in the inner coma, consistent with a large jet blasting material toward the sun. Space.com's coverage of the same event describes it in plain terms: uneven heating, a weak-patched subsurface gas pressure, and then an eruption through the surface that sends material outward, sometimes in a direction that points roughly sunward, depending on local topography and active vent geometry. The important part is not that a jet exists. It is that jets can be new. A comet is not a single, uniform snowball. It is layered, it is patched, it is crusted.
When they start out, they're very
Some regions
pristine.
are sealed by refractory
they
dust.
intersolar system.
Some are
And
freshly
as those
exposed.
volatile
Some contain
gases
volatiles that
are
respond
heated
at
up by the
different
sun,
temperatures.
They erode away.
When the sun's heat penetrates unevenly, the comet's active vents can migrate, shut down, or suddenly turn on. So when the reports say, activating new jets, I interpret that as an evolving distribution of active vents. The surface is not just venting, it is selecting where venting can happen in response to thermal stress cracking and the progressive exposure of fresh material. And because this is an interstellar comet, its surface history may be extreme. It may have spent vast spans of time irradiated in interstellar space-building crusts and altered layers that do not behave exactly like the comets we grew up with. That is why every new jet is not just a feature. It is a probe that is drilling into its own past. 3 deeper interior layers, the delayed heat wave, and the idea of ice volcanoes. Here is where the story gets scientifically delicious. A lot of people imagine a comet reacting instantly to sunlight like a cold object suddenly placed in a warm room. But real comet nuclei have thermal inertia. Heat takes time to propagate inward. That means the biggest changes do not always happen at the moment of closest approach. They can happen later as the heat wave penetrates deeper and reaches new reservoirs of volatile material. A Noir Lab write-up of Gemini North observations captures this perfectly. Many comets have a delayed reaction because of the lag time it takes for heat to make its way through the interior, and that delay can activate new chemistry or trigger an outburst. Now connect that to what observers think they are seeing on 3IATLAS. A recent preprint based on Spanish observations has been discussed widely in science press, the suggestion that 3IATLAS may be exhibiting cryovolcanism, colloquially called ice volcanoes. The idea is not that this comet is literally a miniature Enceladus with subsurface oceans, but that as heating crosses certain thresholds, volatile ices such as solid carbon dioxide can sublimate and drive vigorous jets, potentially aided by internal chemical reactions involving reactive grains and sulfides. The key phrase in my mind is deeper interior layers. If heat is now reaching material that has not been thermally processed during this solar passage until recently, the comet's activity pattern can accelerate rather than diminish. New vents can open. New jets can switch on. Older jets can change direction as the local surface erodes. Spiral structures can sharpen because the emission becomes more collimated. In other words, the comet does not need to be approaching the sun to be changing. It only needs the interior to still be catching up. This is how a comet becomes a moving target for anyone trying to model it. You're not just tracking an orbit. You're tracking a body that is actively reshaping its own outgassing field. For what NASA's spacecraft actually measured: water, hydrogen, and a close Mars view. Now I want to anchor this mystery in the hardest data. In early October 2025, NASA's Mars spacecraft had what the agency described as front row seats. Mars Reconnaissance Orbiter aimed high-rise at the comet, producing one of the closest views any NASA spacecraft was expected to get. That image is not just pretty, it is diagnostic. The coma appears as a cloud of dust and ice, and further analysis can help constrain nucleus size and particle properties. Even more important, MAVEN captured ultraviolet images that detected hydrogen atoms associated with the comet, and NASA explicitly points to using those observations to determine chemical makeup and quantify water vapor released as the sun warmed the comet. This is the difference between we saw it and we measured it. A jet in a visible image tells me something is erupting. Hydrogen in ultraviolet tells me something about what is erupting and how intensely. And NASA did not only rely on
The beautiful
Mars.
thing about
Their multiple
comet
lenses
is-
compilation shows
But
how
where
a
does
whole
their
fleet of
elusive prey
missions
come from?
contributed sun-watching
And then there are long-period
spacecraft,
comets.
like Stereo and
vast majority
SOHO,
of them
tracked it near the
orbiting
sun
in the same
when
direction as the
ground-based
planets are
telescopes could
orbiting
not
the sun.
punch,
And as we
captured
go
it
out
in
further
combined
and further,
observations,
so-called
and even
Oort
Psyche
cloud,
and Lucy
which is a
gathered
spherical
images that
distribution
help
of
refine
comets
the comet's
surrounding the
trajectory.
sun.
and characterize its coma and tail. So, when I say NASA just saw this today, I am not describing a single picture. I am describing a networked observing moment where different instruments are catching different layers of the same phenomenon. If the comet is venting from deeper layers, that should show up as changes in gas species brightness behavior and coma morphology over time. The system is built to watch for exactly that. 5. Why the evolution looks faster. Outgassing trajectory, refinement, and the difficulty of prediction. There is another reason this rapid evolution matters, and it is not just aesthetic. Comets are hard to predict because they are not passive rocks. As gas vents, it produces non-gravitational forces. Tiny thrusts that can nudge the trajectory. That makes precise astrometry challenging, especially when the coma is changing brightness and size. That is one reason the UN-associated International Asteroid Warning Network is using 3IATLAS as a major coordinated observing campaign with NASA, coordinating the effort to strengthen tracking techniques. And it is why Mars data became unusually valuable. ESA explains that using Mars orbiter observations to refine the comet's path was a challenge in part because the instrument was not designed for this kind of sky tracking, yet it was aimed away from Mars to catch the comet sweeping by. This is what evolving faster than expected can mean in practice. It can mean more than it got brighter. It can mean the uncertainty cloud around predictions shrinks, then expands, then shrinks again, depending on whether new jets introduce new thrust vectors. It can mean models must be updated, not just with new positional data, but with new assumptions about activity state. And that brings me back to the spirals and jets. If the coma is showing spiral structure and jets are switching on in new places, that can change how the comet's center of light is measured and how the orbit is fit. In the language of tracking, the object becomes harder to treat as a point mass because it is a moving fountain wrapped in a glowing cloud. That difficulty is not a problem. It is the science. It is the reason interstellar comets are so valuable. They force our models to confront reality. 6. What this could lead to. Next, the close approach and the next activation window. Now I want to open the future because this is where suspense becomes honest. 3IATLAS makes its closest approach to Earth on December 19, 2025, staying far and safe roughly 167 million miles away. Even as it fades on the way out, it remains an object backyard astronomers can attempt with telescopes and professionals can continue to dissect with sensitive instruments. But the real question is not will it look pretty. The real question is whether delayed interior heating will keep activating new behavior after the geometry of the flyby. Gemini North observations already framed the unknown clearly comets can experience delayed reactions as heat propagates inward and that delay can trigger new chemistry or outbursts. If the cryovolcanism interpretation continues to hold up under review, the implication is that 3IATLAS may have volatile reservoirs and reactive materials that can sustain structured jets longer than we expect. And remember, NASA spacecraft data is not only about pictures. MAVEN's ultraviolet detections of hydrogen are the kind of measurement that can reveal whether water release increases, decreases, or changes character as the comet cools. So here is the forecast I'm willing to make grounded in comet physics rather than hype. If the interior heat wave is still migrating, I expect continued reconfiguration. Not constant fireworks, but intermittent shifts. A new vent. A change in coma asymmetry. A tightening of spirostructure. A sudden brightening that lasts a day then fades. The kind of changes that force observers to keep checking because the object is not finished telling us what it is. That is the quiet truth of this interstellar visitor. It is not just passing through our solar system. It is revealing itself in layers timed by heat rotation chemistry and fracture. And every time a new jet switches on it is as if a deeper page of its history is being exposed to sunlight for the first time in who knows how long. NASA just saw this today. And the most unsettling part, scientifically, is not that we saw something unexpected. It is that 3IATLAS is still changing in ways that make tomorrow's data genuinely worth waiting for.